Thanks, Linda. I guess I'm not, it's not uncommon for me to be the only bureaucrat speaking at any kind of forum that involves no other government departments. And I've come to realise that I really do need to put a bit of a disclaimer in here about my role in government. I represent New South Wales Health, and particularly environmental health. Now, I'm an environmentalist as much as everyone else in this room, but my role in this issue is the effect of environmental degradation or other environmental changes on human health, not on the environment itself. So while most environmental degradation issues or disturbances in the environment that cause major problems environmentally, often also cause human health issues, but not always. So our role in New South Wales Health is to advise on human health risks, adequacy of applications for people wanting to do developments such as coal terminal, new coal seam gas developments, coal mines, etc., and then comment on whether they've actually covered the territory, looking at what the potential risk to human health is. Our other roles are in risk communication, and that goes two ways. One is to communicate what the real risks are and what the potential for human health risks are for any kind of development, but also to reassure people if we find that there actually is none or insignificant risk to human health. So we actually should do both. I want to just cover a couple of slides looking at the major potential human health risks from certain types of development. This is where windmills will come in, as you'll find out in a minute. The first is on coal. In coal, we have some unequivocal evidence that particulate matter can kill people. It's the major cause of preventable death in the Western world, bar none. So most people don't realise that that is the greatest cause, preventable cause, that we can actually save billions of dollars and hundreds of thousands of lives just by reducing particulate matter in our urban and rural environments. The issue with that is coal mines do cause dust. We get dust, particulate matter from a range of sources. Cutting into open cut coal mines, you get overburden dust blowing off, you get coal dust blowing off the back of trains, you get diesel emissions from off-road diesel, you get diesel emissions from ships coming in to take coal away, you get diesel emissions from trains transporting the substances, plus you get other types of emissions as well. So there's a range of particulate matter issues with coal mines, and that's well known and well established, and that's the first thing we ever look at in a health risk assessment. Have they actually characterised how much dust is going to come off this? How does it add to the dust that's already there? And what does this mean to the human health of people surrounding those developments? Noise and vibration. Noise actually is a risk to human health. It's not just an amenity issue. There is reasonable evidence out there to suggest that exposure to noise, particularly nighttime noise, can lead to real pathophysiological human health risks. So there is an issue there that we look at as a second thing. The next thing, of course, is surface and groundwater contamination. And from a human health perspective, we're mainly interested in water that would be used by people for drinking purposes, and whether this is likely to be contaminated with BTEX and other substances that are likely to emanate from coal mines. And the last thing is social impacts. Now, social impacts is the most difficult thing to consider because that has a range of issues in it that have both pathophysiological antecedents, epidemiological and toxicologically proven pathways, and also other issues that are very much more difficult to put our fingers on. And I'll concentrate on that in a moment. Coal seam gas has similar sorts of issues that coal mining has. We've got surface and groundwater contamination. That's the main potential risk that we in health are concerned about. You're probably well aware of the proposed Camden expansion of the coal seam gas mining, and you're probably well aware that that was in the newspapers, and there was lots of headlines around that, including lines that New South Wales Health said no. We actually didn't say no. All we said was that the health risk assessments that were put before us were inadequate. They didn't actually properly examine whether there was any potential risk to human health from these developments. And we said we couldn't agree with any development that went ahead without a proper human health risk assessment. That had the effect, essentially, of changing the government's view on exclusion criteria around coal seam gas. It wasn't what we actually asked the government to do, but the effect was that the expansion in those areas has now stopped. Noise and vibration is an issue with coal seam gas, particularly the noise associated with drilling and fracking and the noise associated with the constant transport of water to and from fracking sites. Particulate matter, that's primarily from transport, where you get dust coming from roads around each of the drilling wells, etc. Fugitive emissions is a possible health consequence, but at this stage it's unclear how much fugitive emissions actually do come from coal seam gases. Gas pipeline incidents are a risk. The probability of that risk is low, but it still needs to be considered. And again, we think about social impacts and how they may occur. Wind farms are a different kettle of fish, but they're in the same sort of zone. These are all, the linking thing for these three is that they're all about providing power and energy, and they're the three major sources for our society of actually getting power. Noise and vibration is something that is promulgated by many as being a major issue for windmills. They cite a thing called infrasound. Infrasound is noise that you can't hear, so it's more akin to vibration. And that there are many papers that will suggest that this may be a potential human health risk. None of them published. The published literature doesn't seem to suggest that at all. Particulate matter, again, we have an issue with windmills around dirt roads leading to many, many windmills and potential dust coming from those from traffic travelling over that. But that's not really a major issue because there isn't much traffic between windmills most of the time. Blade incidents are something that is again hypothesised rather than actually being a real human health risk. And then we have social impacts, which is again a really important issue for people around wind farm developments. If we want to actually look at a relative ranking of the potential health risks from these developments, you'll see that I've given this a score out of 5 of potential health risk. For coal, particulates really rank high up there. There is no low threshold for health risk from particulates. Doesn't matter how low you get, you still have some health risk from breathing in particulate matter. So there's no threshold. We can't say below a certain level it's all safe. And we know that the higher you get, the more risk there is. Noise and vibration, as I said before, there is definite health risks from noise and vibration, but that's a lesser issue around coal mines. Of course, the closer you get to any coal plant, the more noise you get and the more disturbance you get at night, and there becomes an issue there about whether coal mines should be sited close to large population centres. In fact, whether a coal mine, anybody within a certain range of a coal mine should be bought out of their properties before that coal mine can go ahead. And of course that brings its own problems in terms of who says someone has to go or whether they can go or whether someone will sell, etc. Then there's water contamination issues. Most people protesting against coal seam gas, for example, forget that in coal mines, I know down here they don't, they can interfere with water as much as coal seam gas. So it's a potential major issue for any coal mine development as well as any coal seam gas development. Fugitive emissions, again, occur from coal mines. What you're doing in a coal seam gas is you're sucking methane out of coal seams. When you go coal mining, you have to get rid of the methane in order to be able to coal mine. You either do that in 2 ways. You go underground and suck it out through extraction fans, or you cut in and it just goes straight up when you hit the coal seam. So there are issues of fugitive emissions in coal mining as much as there are in coal seam gas. The last thing is, and you'll see that I've got, against wind farms here, really a negative on all of these areas, and that's based on current published peer-reviewed literature in terms of the risks with the current siting of wind farms anywhere beyond about 800 metres away, and none of these issues appear to carry any real health risk. That may be modified after consideration of the NHMRC expert working group's considerations that I sit on, so don't quote me to say that this is definitely the case. It is not definitely the case at this point. It just appears to be the case from the published literature. The bottom line is social impacts, and you'll see that I've got major concerns across all three of these developments. Now, if I had to rank these three developments in terms of potential for risk to human health, coal mining is way up there, coal seam gas has a question mark over it, and windmills have a 0 against it. But the community concern around social impacts is equal on all three of these developments. Social impacts have a range of possible sources. There's the indirect health impacts from things like social cohesion, physical environment changes, access to healthcare may change when developments come into town, etc. And there may be things that change in a town centre itself, like walkability and access to services. They're the indirect health impacts. There's the major issue of outrage. People get outraged whenever their local environment has been spoiled in their view. That can manifest itself in psychosocial factors that can have an effect on perceived anxiety, depression. Solastalgia was mentioned earlier by James, loss of distress about loss of environment. For all of these issues, though, there doesn't appear to be any really good documented pathophysiological pathway. So how you actually value this in terms of health outcomes is a problematic issue. Things that exacerbate or mitigate against social impacts from outrage. Exacerbating is poor communication or consultation. And we've heard already about inadequate consultation with community and with relevant stakeholder groups. Non-transparency of what's actually going to happen, what's been planned, how it's been planned, what are the real risks, what are the other factors that are going to be occurring here. The third one is an important issue, and that's inappropriate claims by lobbyists, activists or self-interest groups. If they're over the top and outrageous, they can actually engender anxiety in a community and cause problems that may not have existed otherwise. There's some quite good evidence on this. I've put a couple of references in there by Simon Chapman and Felicity Crichton's recent work looking at nocebo effects. And there's ignorance or misrepresentation of hazard without exposure pathways. In other words, people concentrate on the fact that a development is going to lead to exposure to, or rather lead to emissions that perhaps may be even carcinogenic, definitely can cause human health problems, such as fracking materials, etc. But they ignore the issue that for a human health to be at risk, you need an exposure pathway. In other words, you might have a hazard, like you've got a poison in the kitchen or the bathroom, but if you don't drink it, you don't get to it, then you actually don't get sick from it. And it's the same thing with any emissions or any other factors that emanate from a development. The bottom line is that you actually have to have an exposure pathway before that becomes an issue. Mitigating, you've got good communication, that's the primary issue. You have to have good communication, and you have to have clear presentation of potential risks and of benefits. Most people have seen the risk is hazard plus outrage issue that Salmon popularised back in the 80s. That hasn't really changed. The hazard is the thing that will actually cause toxicological problems and health risks, and the outrage is the other factors on top of that that people are worried about. However, what this equation doesn't really bring out properly is that the health risk is a combination of the hazard itself plus the exposure pathway about how that hazard gets to a human and what the exposure levels are by the time they get to a human. I can give an example here of water quality. In drinking water, we have NHMRC water quality guidelines that all water utilities must follow. They include limits on a whole range of pollutants in the drinking water, including about 30 carcinogens. However, the NHMRC Water Quality Advisory Committee that I sit on has put limits on those, and they're based on how much excess risk you can have from exposure to each of these particular types of pollutants in the water supply. The issue with that is that you can't get rid of these things. They're there anyway. It's the same with particulate matter. Particulate matter is everywhere. It's a health risk. It can kill you, even at low levels. All you can do is try to put limits on how much of that you're exposed to. This is an interesting quote that I'll let you read. This was by Sandman back in 1987. We're talking, 26 years ago, so it's a long time ago now. But this will highlight the fact that people like me who've been brought up in a very rational way of thinking about the universe, who are professors of epidemiology who've published 200 papers, who understand all there is about methodology and will quite happily see that there is or is not a risk in a particular area and what level of risk that is, may in fact miss the boat in communicating this to the community if we don't engage properly and deal with the outrage elements as well. I would hope I'm not irrational, but just reinforce the fact that for a proper health risk assessment of any kind of development, we need to know what the exposure type is, what the hazard is. Is it particulate matter? Is it some kind of poison, etc.? What are the levels of that? What are the pathways for exposure? What's the toxicology or epidemiology? What's the evidence that that exposure level is likely to cause human health risk? And therefore, what's the risk characterisation of that? Now, if you use coal seam gas as an example, you put down fracking material, some of which may in fact be quite poisonous. You put it through a coal seam, and that may absorb particular pollutants such as BTEX. That may then go through and pollute groundwater or surface water, or escape to the atmosphere in terms of emissions from methane, etc. The issue that we have with coal seam gas, and the reason I put question marks around that in the exposure of health risk issues, are that if you put down all the fracking material and you get it all back up because you have good well integrity and because there are no fault lines and the hydrogeology is such that there's aquatards that stop the coal seams interacting with aquifers, then you've got a closed system and there's no risk to human health of people away from there. However, if the hydrogeology is different from that and you actually have leakage of all of that, then we need to know what the flow rate is, what the concentration levels are likely to be by the time it gets to any sensitive human health receptor, to find out what the actual risk to them is and then quantify that risk. And the real issue that I want to highlight here is if we look at the fourth dot point down, communicating risk requires acknowledgement of societal risk appetite. In other words, how much risk will we as a society have an appetite for? For drink driving, we'll accept 10 to the minus 2 excess risk above and beyond what is normally going to happen for early death. So in other words, if your rate is 1 in 1,000, we'll accept 1 in 100 beyond that as well. With drinking water, we're talking about 10 to the minus 4 to 10 to the minus 5. For radiation, we accept 10 to the minus 6. What do we accept for particulate matter? What do we accept for other exposures? That is not a scientific decision. I can do the calculations. I've done the calculations. I've developed incremental guidelines for particulate matter. They are scientifically correct, but depend on what is the risk appetite. The risk appetite is something that is drawn from communities' expectation of what excess risk they're willing to take. So it's a community/political decision, not a scientific decision. Okay, I'll leave it there. Thanks. this issue is the effect of environmental degradation or other environmental changes on human health, not on the environment itself. So while most environmental degradation issues or disturbances in the environment that cause major problems environmentally often also cause human health issues, but not always. So our role in New South Wales Health is to advise on human health risks, adequacy of applications for people wanting to do developments such as coal terminal, new coal seam gas developments, coal mines, etc., and then comment. Thanks, Linda. I guess I'm not, it's not uncommon for me to be the only bureaucrat speaking at any kind of forum that involves no other government departments. And I've come to realise that I really do need to put a bit of a disclaimer in here about my role in government. I represent New South Wales Health, and particularly environmental health. Now, I'm an environmentalist as much as everyone else in this room, but on whether they've actually covered the territory looking at what the potential risk to human health is. Our other roles in risk communication, and that goes two ways. One is to communicate what the real risks are and what the potential for human health risks are for any kind of development, but also to reassure people if we find that there actually is none or insignificant risk to human health. So we actually should do both. I want to just cover a couple of slides looking at the major potential human health risks from certain types of development. This is where windmills will come in, as you'll find out in a minute. The first is on coal. In coal, we have some unequivocal evidence that particulate coal away. You get diesel emissions from trains transporting the substances, plus you get other types of emissions as well. So there's a range of particulate matter issues with coal mines, and that's well known and well established, and that's the first thing we ever look at in a health risk assessment. Have they actually characterised how much dust is going to come off this? How does it add to the dust that's already there? And what does this mean to the human health of people surrounding those developments? Noise and vibration. Noise actually is a risk to human health. It's not just an amenity issue. There is reasonable evidence out there to suggest that exposure to noise, particularly nighttime noise, can lead to a real pathophysiological human health matter, can kill people. It's the major cause of preventable death in the Western world, bar none. So most people don't realise that that is the greatest cause, preventable cause, that we can actually save billions of dollars and hundreds of thousands of lives just by reducing particulate matter in our urban and rural environments. The issue with that is coal mines do cause dust. We get dust, particulate matter from a range of sources. Cutting into open cut coal mines, you get overburden dust blowing off. You get coal dust blowing off the back of trains. You get diesel emissions from off-road diesel. You get diesel emissions from ships coming in to take